Stan Gibilisco here, proprietor and operator of amateur radio station W1GV Whiskey 1. Good vibrations at your service to talk about antenna loading with capacitors. I just recently made a video about how to use a loading coil in an antenna, but rarely will you see, or less often will you see, antennas loaded with capacitors, but it can in fact be done. Consider, for example, a ground plane antenna. And let's just suppose that this antenna is designed for 14 megahertz. So you have a quarter of a wavelength radiating element and at least 3, but maybe 4 or more quarter wavelength radial wires extending out. These are connected to the shield or braid of the coax, these radials. The center conductor of the coax goes straight to the radiating element of your ground plane antenna. You want to elevate this radial system at least a quarter of a wavelength above the actual Earth so that it acts as a counterpoise more effectively without getting the Earth involved in the loss situation. That's a topic for another video. I'll have to do that sometime. You get about 37 ohms of purely resistive impedance at the feed point when you have an antenna like this under ideal conditions, and that will produce a standing wave ratio of around 1.5 to 1 or thereabouts. Well, I have found, and that is because the radiation resistance of this quarter wavelength is a 37 ohms. If you were to make that a little bit longer, say around 22 feet instead of 16 feet, ordinarily on 14 megahertz, these radials, quarter of a wavelength physically, and the vertical radiating element physically would be about 16 feet. You leave the radials resonant by themselves at 16 feet. But you extend the vertical element higher up. Well, let me erase this. There's a reason for that. You extend that vertical element higher so that maybe it's about 22 feet high. And I have actually constructed this antenna so that I know that it does in fact work. Then you feed that element through a capacitor. Capacitor C. Now this is 22 feet. It's still a quarter of a wavelength electrically if you make that capacitance roughly 50 picofarads. In my experience, that's what works. 50 picofarads of capacitance right there at the feed point, at the base. So you connect that capacitor in series with the radiating element of the antenna and your center conductor of your coax. When you do that, the radiation resistance of this element is closer to 50 ohms. So you're going to find that in fact you get a pretty nearly 1-to-1 SWR. I have measured mine at about 1.2. So it's a very good match. Now there's something interesting about this process. It extends the current loop in the antenna up a little bit higher than just right here at the base, so that instead of the 16-foot case in which the current reaches its loop right at the base, in this situation the current reaches its maximum about maybe 6 feet above the base, and then it's a little bit lower at the base than it is at its maximum. So you get, in effect, more radiating element length in space, and one would be tempted to suppose that that means the antenna would work better. I don't know. I honestly can't tell you that. I really don't know, but the standing wave ratio is lower, and the 50 ohm impedance will result in somewhat lower loss in the overall system, because remember, the efficiency of an antenna depends upon the ratio of the total system resistance pardon me, the radiation resistance to the total system resistance. That means that the higher the radiation resistance at this base feed point, the better off you are, all other things being equal. That's one example of capacitive loading, which I have, in fact, actually tried. And you can use those values as a good starting point if you want to build a roughly 0.62 wavelength, pardon me, 0.27 or 28 wavelength vertical on 14 megahertz. You can also do this with dipole antennas. Place capacitors in the center of each side of a dipole so that you can actually make the dipole longer than it would otherwise be. So instead of, say, 32 feet for 20 meters, you might make the thing, 50 feet long for 20 meters. From end to end, 14 megahertz. You would determine these values C by experiment. But then you get into a little bit of a conundrum because your radiation resistance is going to go up so that it's probably going to be closer to 100 ohms at your feed point than the 73 ohms that it would be if you just built a straight away half wave dipole. And with coax here, 50 ohm coax going to your radio, you're going to end up with a 2-to-1 SWR there. Now, for all intents and purposes, in most situations, 2-to-1 is every bit as good as a perfect match. But there's really not as much reason to do this with a dipole antenna anyway, because ground losses and system losses are much less of a factor. But there is a benefit to antenna loading with capacitors that I have discovered by my own experience, and that is that the bandwidth increases. So the antenna will operate over a wider range of frequencies with an acceptable standing wave ratio. Of course, with a dipole like this, it's pretty on the borderline right now already, even at resonance. But with the vertical that I showed you earlier in this video, I have found that the entire 20-meter band is easily under 1.4 to 1 standing wave ratio, a very good arrangement indeed. So that is how you can actually make an antenna physically longer for a given electrical wavelength. This would be, of course, a half electrical wavelength. Because of these capacitors, it would be longer than you would calculate with the traditional formula for determining the length of a dipole. So that's one way to do it. You can try that and let me know how it works, if you want to go ahead and try it. You can also place a lot of capacitors at intervals along lines like this and make it much, 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 much longer. And then feed it with open wire and a transmatch. I'm not sure what the point of that would be. I'm not sure exactly what the radiation pattern would look like, how much improved performance you might actually get. But it's fun to imagine trying it just to see. Stan Gibilisco, W1GV Whiskey 1. Golf Victor in formal terms, saying 73 for now, and so long.